Okay, in this video, I want to do two things. One, I want to solve a past paper, and then I want to continue to build individual supply schedules. 4 or 5 individual supply schedules, we can combine them to form a market supply schedule. So let's begin. Okay, the schedule below shows a short run marginal cost of producing good X. Short run means that we have both fixed costs and variable costs. In the long run, there are no fixed costs. So that's what that means. So for the quantity of 1, the marginal cost is 40. The quantity of 2, the marginal cost is 30, and so on. So one of the first things that I did is I made a table preparing for all the information we need for this question. So instead of saying units of X, I say quantity 1, 2, 3, 4, 5, 6. And given that the total fixed cost is 30, what is the output minimizes the average total cost? So here's the average total cost. Here's our quantity. We're given a marginal cost, fixed cost, and we need to go from these two pieces of information to get all of this information over here. Also, we need to find the minimum average variable cost to figure out what is the minimum amount of supply this firm is willing to produce. So the first thing that I do is I fill in the marginal cost schedule here. I take these numbers here and I put them there: 40, 30, 26, 34, 50, and 90. The fixed costs are 30. This is from IGCE Economics. It just means that no matter what the quantity is, this is the startup cost of our business, 30. So no matter what quantity is, the quantity is increasing, the fixed cost will always be 30. Now, the average cost, total cost, comes from this equation here. Total cost equals fixed cost plus variable cost. So we have total costs, we have fixed costs already established, we have variable costs, but to get average total cost, we need the total cost divided by each quantity. So for example, the total cost here, the average cost here, average total cost will be this total cost divided by 1. And so on. This average cost here is this total cost divided by 2. So we need to fill in these columns as we move along to get this information. So here, this is where I do a cheat. The first thing that I do is I say, what was the total cost when there were 0 units? Again, when there are 0 units, no matter what the quantity is, the fixed cost is the cost at that individual, each quantity, regardless of whether we produce 0, 1, 2, 3, 4, 5, 6, or 120. It didn't matter. We started out with fixed costs of 30. So in the beginning, when a quantity is 0, the fixed cost is 30, and the total cost then for 0 units is 30. Now, as we know, the marginal cost is, as we increase by 1 unit, how much did total cost increase? So here we could say the original total cost was 30 at the quantity of 0, but we increased the quantity by 1, and marginal cost means the cost increased by 40. So we take the original 30 at 0, quantity increased by 1, the cost increased by 40. So 30 plus 40 equals 70. So this is 70, the total cost at the quantity of 1. The quantity of 2, where they say as we went from 1 to 2, the total cost increased by 30. So this is 70 plus 30 equals 100, and so on. And we calculate that for all quantities, the total cost. And we have this information here. Last slide I forgot to mention. When I put these marginal cost totals here, they appeared here. This is a marginal cost curve that corresponds to the marginal cost at each quantity. So at the quantity of 1, the marginal cost is 40. You can see that here. 2, the marginal cost is 30, and it goes along there. And the total cost, we're filling in the next slide. Okay, as you can see, I filled in the total cost. And using this equation here, total cost equals fixed cost minus variable cost. And then I get, so all I got to do is total cost minus fixed cost, and then I'll be left with variable cost. So total cost is 70 minus 30 gave me 40. And we'll need these variable costs to calculate the average variable cost. Look here again, for the quantity of 2, 100 minus 30 is 70. All right, so finally, though, we have the information to calculate our average total cost. And you can see that the average total cost curve has appeared in our diagram here. And what I've done here is total cost and average total cost. Now, average means the total of anything divided by the quantity. So at this total cost of 70, I divide it by the quantity 1, and I get an average total cost of 70. I have a total cost here of 100. I divide the 100 divided by the quantity there, and that's 2. So this average total cost at each quantity is basically the total cost divided by the quantity at that specific level. And we get these average total costs, and that equals here. So going back to this question, given that the fixed cost is 30, we have this information. What is the level of output that minimizes the